Today we are going to see a special topic regarding how do we produce automated transfer functions from a bond graph model into Simulink. So you see on the screen you have a electrical circuit which is a sixth order system. So it's quite significant if you were to do it by hand. It would be quite lengthy and chances of error, depending on how good you are with algebra. So if you have in here as an objective, the transfer function is the relationship between the output across the C element, in this case the capacitor on the right hand side, which would be element C18. So what you're given right now is you have the system and you have the bond graph model, and the question is, can we obtain the transfer function of the voltage across that capacitor that we know in the bond graph would be C18, the output would be E18, and let's see how we're going to do that. Okay, so once we have stated the problem, our job right now is first to enter this bond graph model into CAMG. So this would be from a bond graph model. I would say, why don't we may even modify the title a little bit, from a bond graph model to a Simulink transfer function. We could say from a bond graph model in CAMG, to a Simulink transfer function. Very good. That's even more precise, the title of what we're doing right now. So to do that, then we're going to have to run the CAMG software first. And so we go over here and we say, okay, let's look for it. BC, there it is, and then we go click. We're gonna run it on a window so that it doesn't become too big, but then leaves space for what we're gonna do with the other windows in here, in the sense that we would like to see it. We would like to see this, and let's see if we can actually do this. This is good, huh? So let's just click over here and make sure that we are running in such a way that we can see the mouse in here. It's a challenge here. Let's see. There we go, and perhaps reduce this so that we can see this, and now we can see this one too. Okay. Let's see. We just have to have the windows in there, and I need to see that we have the mouse. Okay, so we have the cursor on the right hand side, and now we're gonna say do a new file, and what we're doing here is we're going to enter the bond graph model exactly as it is on the left hand side, including the numbers, so that we get a set of values that I already have in mind, and and we won't have to type them in. So we're gonna do exactly as we are having it on the left hand side, and there we have in here, and then this is would be not, we are up to bond number 4. We have to get to bond number 18, right? So this is 4, and then 5, you see it's over here. Hopefully if you're watching this, you might follow me also using the program here. And then you have the C here, and then we have the R element also, and then we do the next one, which is number 8, that goes to a 1 junction over here, and that is like this. And then we put on number 9 the I over here like this, and then we have the R element, which would be number 10 in here, and then we have the 0 junction over here to draw for 11 in here, and then you have this 1. This would be, and then we have the C element over here to give us this, and then R element, which is down here. Yeah, there. We're making good progress. So we are on the home stretch here. We're on the last loop, and this is going to be I-16 here, and then we have the R element, then you have the C over here, and then we have number the R19 here. Very good. So we have completed the bond graph model of exactly as it is on the left hand side. If you want to make this perfect and all line up, come over here where it says move, and then you click the single element. Let's say we move it down a little bit. See, I went too far, and so we say undo. We try again. Say move a single element from, I guess we just need to move it 1. There you go. But we messed up the ones on the right hand side, and so we can also fix those by moving this one in line over here, and then we have one more to move on the see, so that it would line up perfectly well, and it would look exactly as the one on the left hand side. So you can do this and then move this down a little like that. See, to undo. This is making me see this in here. We just need 1, and I did 2 okay. That is perfectly fine. We have exactly the same bond graph model in ChemG as I have it on the notes. And now the idea is to obtain a transfer function for the variable as an output variable E18. And what will happen here at this point, so that this doesn't look like a black box, what happens is that ChemG is going to produce all the state space form and all the matrices of the system with E18 as the output. That's the objective. So we specified so that the transfer function is obtained from the matrices of the system. So once that happens, we have to tell CAMG, please make E18 our output. That's something that we need to do. So in here we go and we say interface to Simulink, and so the program goes and thinks about it for a little bit, and then the two programs are going to negotiate some interface in there, and you can see there MATLAB is coming up. Hopefully it won't take too long, because sometimes the running on a network is slow to get going, but let's hope that it's not so busy. So we get MATLAB, and what's going to happen here? I told you that the computer will produce the state space form, and it will produce a file that would allow us to enter values for this. And then we also want to tell the program that that is the that E18 is our output. So we need to do two things. We need to tell what the output is, and then we need to do the initialization of the values. So it looks okay. There we go. Made us wait a little, but it's coming up. So CAMG and MATLAB have negotiated an interface where you have the bone graft model described in MATLAB in a couple of files that are appropriate for Simulink, and also that it will give us the transfer function, and it would give us also the state space form in Simulink. So we have to wait a little, because this is still not quite there. The two programs are still working together, and what will happen is that we will see those blocks in Simulink at this point right now. So we have to be patient for a little bit, and then we will see. So we're going to see in here on the screen two files, one to initialize and tell the computer what the transfer function is, what the output is, and also would allow us to enter the values. Then one thing you have to understand is that the workspace that the Simulink has is the same as in MATLAB also. So we finally have what we need. So right now we have this, let me just show you in here. Now you have only two files on this interface with CAMG and Simulink. So let's see what it's doing. I think that what we need to do is, let me see if I get the preferences here to modify the display in such a way that you can see it better. Like I am going to make it bigger and make it bold in here, and then you can see it really well. Okay, so let's just go over here and just let's for a moment remind you, I would say just for a second, what the system is. So right here is the output is E18, which is right here, is the voltage across this capacitor right there. Huh? Okay, so we need to initialize the values for all these other elements, and that's where we are over here. This one, you see this, let's read the title. Let's say model parameters initialization file, it says camgini. And then generates this initializes the matrices for this. Okay, this camg TT is the MDL file that Simulink uses. So it says, listen, what are the values of this? See, it's asking you questions here. And then it says, what are the inputs here and the outputs? So the input obviously is SE1, it's a voltage input. That's what we have on the system. And then it derives the equations for the system and the matrices. You see here the first row, second equation right here. Then you have the third equation, and then the third row, and then finally you have, no, finally, this is the fourth. It's pretty long. You can see fourth, fifth, and sixth equations, which otherwise, if you were not to have, if you don't have this program, you would have to do it by hand. And then the computer has produced as outputs every single E and every single F in the bond graph model. We are interested of E18. As we come across, we could, it says right here, we could make a search or for E18, or just go over here and say, you know, I'm really interested in this one. So we're going to do here, and then we go over here and we say, okay, this number one, output number one in here. Okay, all the others who are not interested, we're interested only that. And you say, Professor, isn't it true that we could actually produce all the outputs E and F on the system and obtain the transfer functions for those two simultaneously? Well, yes, but I think it's better to just work with one at this point. So this is an interesting situation. It's unique to this file. You see here, it has a feature that if you want, the computer could define as outputs every single state variable. Yeah. So if you define this I6 like this, means produce the C matrix, and the output is going to be all 6 state variables. So because we want the output to be just one, and we want to let the computer just calculate one transfer function, if I don't modify this, it's going to obtain six of them. So I think I am going to put a percentage sign here, and I say, no, I am interested, just work with one, and then the computer will initialize the matrices, and that's all we're going to do. So in here we have to have numbers in here. We need to have numbers in here. And what we're going to do is go where it says the numbers. You see, now we are going to say where are those values that we had in here. the values that we had in here. See this one's right here. Let's use this. So I am going to copy this and then go to my file over here, and I'm just going to paste this in here because I don't want to be typing all those, but we need to make sure that all of them are defined, you see. Let me just, this is a bit to the left in here. Okay, you see I2 R3, C6 R7, that's doing good. I9, and then we go to the next would be R7, no, R10, C13, R14, I16, R17 in there, and then we have R19, yeah, and C18. So these are all the ones that we have in here. So I'm just going to copy just to have those values on the clipboard, and let's go and run this to obtain the matrices of the system. Okay. Also, we have this file, you know, the num file means anything you have to do with the transfer function, do it you could do it initially in symbolic form, so, or put those numbers. So let me back up a little bit for a second over here. These ones in here are no longer active, otherwise we will crash in here. See, we're gonna go and comment this, meaning use the others. So if we do this in here, we initialize the matrices, and this is very good if we have the state space block in Simulink, which CAMG has already produced for us. So that is this one right here, see? So all those matrices are all initialized. So we could take a peek at this and do it right now. We have one output, as you see, one input, and those matrices initialized. So what we could do is we could say, okay, look, they are all initialized in there. In the background, CAMG knows all the A, B, and C, and D. In fact, just so that you see, if we run this file in here, if we run, watch what will happen. Do you see right here? Here on the left hand side, you also see how it initializes the values in here, but nevertheless, here you can see very clearly you have the matrix. See, first of all, it tells you this is the input. They also say E18 is the output. Okay, so you have A, the matrix in numeric form, then you have B and C, and then you have the D matrix. Okay, so that's that. If you go to the Simulink block in here, let's just do things right. In this case, if we put this as the output and we double click in here, we expect that we will get the output in here. If it has a step input into the system that we already have initialized. You see, if you double click over here, do you see how it has the matrices in there? Okay, that is it has it already in there. Because we run it, those matrices are active. I believe that in here, if we run it like this, let's just make sure that there are no loose ends hanging here. This says that you have two inputs. The way we have it on our end is 1. So let's just do that right. And my output over here also is 1. Okay, so there we go. And if I click on run, I should see the response right here. Let's see if that is the case. Right there. So we're going to go click run. Computer is going to go do these calculations, and hopefully it runs and it gives me, this is the response, you see, right there. But I think it's a good idea to do this. That was the response for this particular system for that step sort of noise in here. We have the values that are in there. This is the voltage, and of course the variations are pretty small, but we could have picked another output in here, like the current, for example, on that loop. What would that be like in here in the initialization file? Let's say, going back to the bone graft model, I'm just going to get one of the current in here, right here. Let's just do like F16 as the current on this, right? So I would just go in here onto into my Simulink model and say, okay, I need to initialize it so that F16 would be another output. So to do that, you go to the file here, and we are going to add one more output, right? So this is, let's see, F16 would be, we go over here and we say, find for me F16. Yeah, and then it's found there, and in here you say output number 2. This is number 2. Yeah, and then right here we can say this is 2, and make this the row number 2, because I want also to see that. Okay, I'm gonna plot 2 outputs now. So if I run it over here and I said, okay, let's close this for now, and you say run, you know, the computer gave me these matrices now with the understanding we have 2 outputs right here, this A, B, and C, and the D for 2 outputs. See that, you can see there's 2 of those. And now that whole thing is initializing here. You have 2 outputs, and you have, what is this? Yeah, this is 1, so this is okay. This we need to say 2 instead of 1. Now this is 2 because we have 2 outputs. See right there? And so what I can do is I can do a copy of that one and just how do we let's just make a copy of it just to make our life easier. So there we go. And we go and put this output like this. Now I am going to also have both of these. Let's see what happens. If I go over here and say run, we have a bit of a noisy response in there, but I think we need to tweak the timing here. But perhaps what we need to do is, you see, it's the time is too long in here. How do we can adjust the properties of the plot to make it a little nicer in here. But nevertheless, this is the response. I think right now we're just taking some values in there that we took just to see what we get.
You adjust that with the next to the plus, I think there is a sheet.
So I initialize the values in here, and when I run the ChemGenome file, I will obtain the response of the system. If I run this, and this would have a step and impulse response for both outputs, and this should be the same thing also in the Simulink side, because the initialization files and the transfer functions that we are looking in here, they are shared with Simulink as well as with MATLAB. In fact, you could look at the two of these transfer functions in here, and it has both of them in numeric form, and those are the ones that are being used to produce the plots that you just saw. So in that regards, you will see when you run that file, the step response, you run the impulse response, but also you have the root locus and body plots for both of those transfer functions, giving you a lot of information about your system.